Good morning. Today we are working on problem 2.3, going back to unit rates and a constant of proportionality. We have talked about unit rates before in comparing bits and pieces. So a unit rate is a rate in which the second quantity is 1 unit. For example, 45 miles per gallon is a unit rate. It's 45 miles per 1 gallon. And $3.50 per hour is also a unit rate because you're getting it down to 1 hour. $3.50 per 1 hour. So those are both unit rates because per gallon means for 1 gallon and per hour means for 1 hour. You may have used the following unit rates in previous problems: the amount of pizza per one person, number of people per pizza, or even the price per pizza. The unit rate for the price of one pizza at Howdy's is $13. We established that yesterday. The equation C, which is cost, equals 13N, N is number of pizzas, relates cost of pizza and number of pizzas. This equation represents a proportional relationship. It is because you multiply one variable by a constant number to get the value of the other variable. So that constant multiplier, which in this case is the 13, is called the constant of proportionality. So we know that this number, the cost, is going to change based on how this number changes. So one pizza is going to be $13. If we change that N to two pizzas, that would be $26, and so on and so forth. That 13 represents the constant of proportionality. Then, when you have a delivery charge added, as we did in yesterday's problem, when you have that delivery charge, you want to show that in the equation as plus 5, right? So then the relationship is no longer proportional because every time you have to add that $5. So that would be cost equals 13N plus 5. It is not a proportional relationship because of the plus 5. Here's problem A. Fresh Foods has oranges on sale at 10 for $2. For each part, find the unit rate. Remember, unit rate is per one. So if it is 10 for $2, how much could you get for? Oh, nope, that's not what it's asking. That's question number 2. Question number 1 is asking, what is the cost per orange? So if it's $2 for 10 oranges, how much does each orange cost? That's what number 1 is asking. Number 2 is asking, how many oranges can you buy for $1? And then you're just going to go ahead and complete this table. I've already given you some text boxes here. How does finding a unit rate help you answer questions such as the ones below? How many oranges can you buy for $5? How much do 25 oranges cost? I should have made those text boxes a little bit longer because that is asking for an explanation, but you guys are tech savvy. You can make that larger. Let's take a look at number 5. The equation N equals 5C relates to cost number of oranges N, right? It's cost to the number. So for example, 5C, that is going to be the cost, equals N. What does this equation tell you about the relationship between the number of oranges and the cost of the oranges? So N is the number of oranges and C is the cost. So this equation is relating that. You are going to analyze that. And, I did give you text box here. So again, you can do this on paper, but if you decide to complete it here, you've got plenty of room in this text box. What does this equation tell you about the relationship between the number of oranges and the cost of oranges? What is another equation relating these two variables? What information does this other equation give you? So maybe you can move around some values to come up with a new equation. Then they're asking you to identify two unit rates from these equations. Explain how you found the unit rates. What information do the unit rates give you? So I'm going to give you a little hint on that one, and that is that when you get it down to $1, that would be a unit rate. So however many oranges you'd get for $1, you would say blank oranges per $1, or you can get it down to cost per one orange. That would also be a unit rate. Now 6A is asking you to make another graph. I know you made one yesterday, so just go ahead and plot out the question, graph the equations from question 5 on two coordinate planes. Show values of n from 1 to 20. So they want you to go ahead and graph the equation. So you would have number of oranges on the x-axis, and your cost would go onto the y-axis. And then there's just a couple questions asking you about the graphs. Norley's car uses 20 gallons of gasoline to go 600 miles. They want you to write two unit rates. I left you a text box here. So you can get it down to how many gallons of gasoline does she use to go 1 mile. Then you can also use as a unit rate, how many miles can she go with 1 gallon? Okay, so remember for unit rate, you're getting it down to 1, and you can go gallons to miles or miles to gallons. And they just want you to explain what each unit rate means. This graph shows the relationship between the distance and the gallons of gasoline. Which unit rate appears on the graph? So, oh yeah, there's only one. So you'll be fine with that one. For 3, it's the equation relating, what equation relating D and G does the graph represent? So you are being asked here to come up with an equation regarding distance to gallons. Which coordinate pair represents how far Nora Lee can drive on 1 gallon of gas? How about on 0 gallons of gas? And then you can answer number 5. This is going back to proportions. If you have 600 to 20 and x to 4 equals x over 4, you can use that to find the number of miles. So that's what you're going to do. Lisa says she can use a unit rate. Do you agree with Josh or Lisa? Because Josh is using this proportion. Where's Lisa? Oh, here. Lisa says she can use a unit rate. So which one do you think makes the most sense and why? And then for 5B, what other strategies can you use to find the number of miles Nora Lee's car can travel on 4 gallons of gasoline? So they've given you the example of the proportion. Is there another way, another strategy that you can use to get that answer? Gus wants to determine which store has a better price for groceries. So, what information does Gus get from solving these proportions? At More for Your Money, pasta is 7 boxes for $6. Gus makes a unit rate table and writes the proportion 7/6 equals N over 1 and 6/7 equals C over 1. What information is he solving? For this one, I did not make text boxes. You're going to have to make your own. This is just filling in this rate table. So we know that he gets 7 boxes for $6. How many boxes would he get for $1? And then, so this is a unit rate, of course, right? Getting it down to 1. And then what would be the cost for 1 box? You may use a calculator for this page. And then you're going to answer questions 3 and 4. If you have any questions at all, oh, you also have just one ACE problem tonight. You're just going to go ahead and do that number 8. ACE problem number 8. And if you have any questions, come on over to office hours and I will help you. Make it a great day.